Hey y'all, it's Mrs. Blasky. Video today is a little bit different than normal. This is not a specific content area of chemistry, but this is a way of thinking and a way of explaining things that's going to come in very handy when we are explaining free response questions, but also in the way that you think about science and chemistry and how you look at the world, to be totally honest. So this is a process called claim evidence reasoning. Sometimes we are going to abbreviate it CER. And the big idea of this is that the world is full of people claiming that things are true. The world is not science. People don't always listen to science. People don't always understand science well enough to be able to make informed decisions. And so something is either true or it is false, but we need to say why we know it is true, why we know it is false, what evidence backs up that claim. And evidence, even in of itself, can be good evidence or bad evidence. So funny little cartoon here, a stinky booger face was the evidence-based. Are you actually a stinky booger face? Do you smell? Do you have boogers on your face? Sort of a joke. So the big thing about whether something is credible or not, whether we can really believe it or not, whether we can defend it, whether there is evidence. So we always talk about how evidence is the foundation. So we can see here that this claim, this yellow claim here, is supported by a whole lot of evidence. It is nice and sturdily supported. It has a nice strong foundation of evidence. So we could say that that evidence helps support that claim. Whether that evidence proves that it is true or proves that it is false, we've got that there. If you have a tiny bit of evidence or no evidence at all, you have no good foundation for the credibility of your claim. So as scientists, you guys are not scientists yet. If you want to become scientists, if you want to think about the world like a scientist, we're looking for evidence. Rather than just listening to somebody, what they say, and not thinking about whether their evidence is good or bad evidence, or if we like what they're saying, is very different, especially in this world today where information is so readily available with social media and internet. People can say whatever they want. And if enough people share it, if enough people retweet it, then people start to think that that is truth without really analyzing what's going on. And bad evidence can look really promising. But really analyzing that evidence and saying, does it really support your claim? How did you arrive at that evidence? What's going on with it? So Neil deGrasse Tyson, one of my favorite guys in the world, what we're talking about right now is called scientific literacy. Can you think about science the way that scientists do? Do you understand how science works? Do you understand how this process of claims-based evidence works? So here's an example of an answer that I could get in class. We're not even going super deep about this. What can you conclude about the identity of object A, B, and C? This was from an experiment where we had 3 unknown objects. We had to measure their densities to determine what substance they were made out of. So object A and B are tin and object C is lead. The density of object A, the density of object B. Based on this evidence, this proves that we are right. What's proving that you're right? Nothing. All you've done is told me what the densities are. We would need to talk about comparing it to known information. We would have to talk about how A and B are the same. They didn't even talk about anything about C. And what are you right about? Did you predict that that was going to be true? None of this, there's no evidence. And it's not supporting your claim. You're missing the connection between the data and your claim. How does that reasoning fit into there? So science is all about making sense of our phenomena, looking at the world, measuring things, seeing what's going on. And we have to go through this process of conducting scientific explanations to make sense of what you're learning. If you don't try and explain what you're learning, you're not actually learning it. If you can't understand why it's happening, if you can't explain why this situation is different from some other situation, you don't really know it. So that's what we're going to talk about. So when we're talking about this 3-part explanation, this 3-part thinking, First part is claims. A claim is short, sweet, to the point, saying this is what we think. The claim is, I think that compound A is tin. Or I think that masks prevent against coronavirus spread. That's your claim. It does not start with a yes or no. It's very specific. There should be no questions about what you are trying to defend. It's not, we want to talk about covalent bonding. The claim could be, this specific compound contains covalent bonding. The evidence that you support is the data or findings from your investigation or research. It doesn't have to be from an experiment. It could be that you've looked up things that somebody else has done. It could be that you've looked up information about other things. You've collected it, you've analyzed it, you've interpreted it in a way that supports your claim. Let me move my face so we can actually see the rest of this. It is made up of data, the analysis of that data, and the interpretation of that data. All of that, all at the same time, is in there. You need to have enough evidence to support your claim. It needs to be the appropriate data. It might not be your straight up raw data. It might be that you've analyzed it already. There could be graphs, there could be equations, there could be pictures, there could be data tables, all kinds of things. You've already gone through and analyzed the data. It can't just be pop, here's my data table, there's my evidence. You need to say what of that data is important. What does that data show you about what's going on? And so that's this interpretation part. What does your data actually mean? And then the reasoning. People lots of times get the evidence and the reasoning confused. So the reasoning explains the importance of that evidence by making it very explicit about what that analysis says. It's sort of like a conclusion, but not a wrap-up kind of conclusion, like a so there conclusion. Like, this is what I thought, here's all the data I did, here's my analysis, and my reasoning is, ha, see, because of this data, I can see the connection between point A and point B. We can also pull some scientific principles into here. So if we need to talk about the law of conservation of mass, if you need to talk about gravity, if you need to talk about inverse proportionality or direct proportionality or different ideas like that, it can all go into your reasoning. We're going to practice this several times in class, but the idea that all three of these parts are connected to each other, that the claim, the evidence, and the justification or the reasoning are all connected to each other. You cannot explain something without all three parts. Right? There's no one specific correct way to do this. It doesn't have to be necessarily in that order. Sometimes you might come up with your evidence first, and it helps you support your claim that way or figure out what your claim is. Different groups, different careers use this. When I was researching this information, scientists use it. Scientists always have sort of thought this way. This is the scientific process of the way of thinking. Lawyers use the same process because they need to defend based on the laws, based on the precedents, based on, what am I trying to think of? Evidence, right? Like literally like crime evidence. They can defend or refute different things. So scientists is not the only ones who use this. Here are some examples. We're actually going to do some of these examples in class, but I just want to show you this real quick, just to show you that just because something looks good, something that has got everything in there, doesn't necessarily mean that it's good evidence. So guiding question here is, so this is not the claim. The guiding question is, what are the identities of A, B, and C? The claim is that object A and B are tin, object C is lead. That's a very specific, straightforward claim. That's what they are. They're giving evidence of the densities. They're not comparing that density to any known. They're not doing any sort of analysis of the densities. They're just saying, this is the densities. The justification is true, but they're not using their evidence to help support their claim. they're really not referring back to that and saying, well, why do I want the densities to be the same? Why is that an important thing? The difference is, here's a better one. Same guiding question, same claim. Density of object A is this number, the density of object B is this number. That's the exact same data that the person before this gave. But their evidence, they're analyzing this evidence now. They're analyzing their data saying these objects have almost the same density as the known density of tin. Density of C is this is the same as the known density of lead. So they're actually analyzing that data. So they are justifying that object A and B are tin by saying that since density is a physical property of matter, it remains constant regardless of the amount of the object present. That's a scientific principle, right? That's sort of a density, a definition. And then they're saying, well, we can use density to identify a substance because it is a physical property. And they're doing a little bit of error analysis also of saying, we know that it's not exactly the same, but that can be accounted for in terms of experimental error. Okay. This idea of using your evidence and a justification to support your claim, we are going to use this in our free response work, especially this unit when we're talking about periodic trends. That's why I'm introducing it now. So we're going to work in class on building this idea of how do we write good evidence, how do we analyze it, and how do we use that to write good justifications or reasonings. Right? So we will practice this more in class. I will see you all later. Bye.